Welcome back to Think Thrice. Today we're going to be solving another Putnam exam problem. Let's take a look at it. So this one's a little bit straightforward. It's just math. So we have, this is from the 2021 Putnam exam, and I called it the impossible limits. So it says for all real numbers x, the function g of x is equal to the limit as r approaches 0 of x plus 1 to the r plus 1 minus x to the r plus 1 all to the 1 over r power. And our goal is to find the limit as x approaches infinity of g of x over x. All right, so if you'd like to work on this on your own, please pause the video, take a few minutes, see if you can figure this one out. Otherwise, let's go ahead and jump into the fun solution. So the first thing we're going to do as we look at this is we're going to notice that we see exponents on the right side. So we see this function of r raised to the 1 over r power. So that 1 over r is pretty nasty. So a lot of times when we see problems like this, we should be thinking natural log. So let's see what happens to this guy if I take log of both sides. So if I take log of the left and I take the log of the right is the same, so let's take the limit as r approaches 0 of log of x plus 1 to the r plus 1 minus x to the r plus 1 all to the 1 over r. And remember, when we have an exponent within a log function, we can pull that guy out. So let's take this 1 over r, and let's rewrite this now as the limit as r approaches 0 of 1 over r times the log. So I'm just going to write the whole statement over r, and inside we're going to have x plus 1 to the r plus 1 minus x to the r plus 1. All right, so we have a little bit of a different statement in here. So now what I want you to see is as r approaches 0, I'm going to have r approaching 0 in the denominator. And on the top, I'm going to have x plus 1 to the 1 minus x, which is just going to be log of 1. So this is going to approach log of 1, which is 0. So I'm going to have 0 over 0. So a lot of you are probably screaming at your computer now. This looks like L'Hopital's rule. So let's go ahead and look at this and try L'Hopital's rule. So what we're going to do is we're going to take the derivative of the top and the derivative of the bottom. So we're going to use L'Hopital's rule. And once we take the derivative of the top, so the derivative of the top is going to be, so we're still going to have the limit as r approaches 0. And now we're going to have 1 over x plus 1 to the r plus 1 minus x to the r plus 1. We're going to have that multiplied by the derivative of the inside. And the derivative of the inside, remember x plus 1, so we're taking the derivative with respect to r. So we have x plus 1 to the r plus 1 times the log of x plus 1. We're going to have that minus x to the r plus 1 times the log of x by itself. So that was the derivative of the top. And we're going to multiply that by 1 over the derivative of the bottom. So the derivative of the bottom here is going to be 1. So now we have a little bit of a different expression here. So what we notice is that I can rewrite this now. This is the limit as r approaches 0. If r approaches 0 now, I no longer have a problem because I'll just have x plus 1 to the r minus x to the r, x plus 1 to the r on the top, x to the r plus 1. So now I'm not getting any zeros anywhere. So now I can go ahead and take that limit. So let's take that limit, and I'm going to get x plus 1 times the natural log of x plus 1 minus x times the natural log of x, all divided by x plus 1 raised to the first power minus x raised to the first power. So we have a few things cancel. So this x and this x go away. I'm just going to do that over 1. And now this is looking pretty darn neat. So I'm going to rewrite this now. So now I'm going to have x plus 1 times the natural log of x plus 1 minus x times the natural log of x. So we can do a little bit of work here with our natural log rules. So I can rewrite this now as the natural log of x plus 1 raised to the x plus 1 power. And it's minus x ln of x, so I can do that multiplied by x raised to the negative x power. Okay, I kind of combined two steps there, but you can see how I'm using the log rules together here. And remember what we started off with was that this is the natural log of g of x. So let's go ahead and kill that log now. And we're going to be left with g of x is equal to x plus 1 raised to the x plus 1 power times x to the negative x. All right, so this is looking pretty good. So let's recall our original question. So our goal is to find the limit as x approaches infinity of g of x over x. Okay, so let's go ahead and write this out now. So we're finding the limit as x approaches infinity of g of x, which is x plus 1 to the x plus 1, times x to the negative x. So let's go ahead and just put that in the denominator. So that's x to the x in the denominator, times x, and that last x is coming from right here. All right, so we can combine these now, and we can see that this is equal to the limit as x approaches infinity of x plus 1 raised to the x plus 1 power divided by x raised to the x plus 1 power. So hopefully you're seeing where we're going here. So we're going to combine those now. And we're going to get x plus 1 over x raised to the x plus 1 power, which I can then write as 1 plus 1 over x raised to the x plus 1. Okay, which is almost something that's very nice. So what I'm going to do here is I'm going to separate this. I'm going to look at this exponent here, and I'm going to rewrite this now as the limit as x approaches infinity of 1 plus 1 over x raised to the first power times 1 plus 1 over x raised to the x. And what we notice here, so this guy, the first guy, the 1 over x approaches 0. So this whole thing is going to approach 1. And this guy over here may or may not look familiar to you, but this is actually the exact representation, the limit as x approaches infinity of 1 plus 1 over x to the x is e. So this entire thing right here will go to e. So our final answer after all of this, elegantly, is just going to be E, which is pretty darn cool. So I hope you enjoyed walking through this problem with me. I had a lot of fun working through it the first time. And you get to do some cool things with limits. If you enjoyed this video, please go ahead and like and subscribe. Feel free to submit your own videos if you'd like to see me work through something. And as you're working on your own problems, always remember, if you get stuck, think once, think twice, think thrice. Have a great day.